Imagine you're at a bustling market with many vendors shouting their wares. It's noisy and confusing. To solve this, imagine each vendor gets a designated area to sell their products. This organized approach makes it easier for shoppers to find what they want. FDMA, or Frequency Division Multiple Access, does something similar in computer networks. Instead of vendors and stalls, we have devices and frequencies. FDMA divides a large frequency band into smaller channels. Each device gets its own channel to transmit data, preventing interference and chaos. This organized use of frequencies is crucial for various communication technologies, ensuring smooth and efficient data transmission. Understanding FDMA helps us appreciate the elegant solutions that underpin our connected world. Imagine a large pipe carrying water. Now imagine dividing this pipe into several smaller pipes, each carrying a portion of the water. FDMA works similarly but with frequencies instead of water. In FDMA, a wide frequency band is divided into smaller, fixed-frequency bands called channels. Each channel is like a dedicated lane on a highway, allowing one device to transmit data without colliding with others. For example, in satellite communication, FDMA allocates specific frequency bands to different Earth stations. This allows multiple stations to communicate with the satellite simultaneously without interfering with each other. This efficient use of the electromagnetic spectrum is vital for various applications, including television broadcasting and mobile phone networks. FDMA offers several advantages due to its straightforward and organized approach to frequency allocation. Firstly, it ensures minimal interference between devices. Since each device has its own dedicated frequency channel, there are no collisions or overlaps in data transmission. This dedicated bandwidth allocation leads to more reliable communication, especially in scenarios with a fixed number of users and predictable data needs. Secondly, FDMA implementation is relatively simple compared to other multiple access techniques. This simplicity makes it a cost-effective solution, particularly for systems with a limited number of users and where the data rates are not very high. These advantages make FDMA suitable for applications like satellite communication and early cellular networks. It provides a reliable and efficient way to manage multiple users, sharing a limited frequency spectrum. While FDMA offers a simple and effective way to manage multiple access, it comes with some drawbacks that limit its suitability for modern communication systems. One major disadvantage is its inefficiency in handling dynamic bandwidth allocation. As each channel is permanently assigned, even if a user is not transmitting data, the channel remains idle. This fixed channel allocation leads to wasted bandwidth, especially in systems where data traffic fluctuates. Furthermore, FDMA struggles to accommodate a large number of users efficiently. As the number of users increases, the number of channels required also increases, potentially leading to bandwidth limitations. This limitation makes FDMA unsuitable for high-density networks like modern cellular systems where thousands of users share the same frequency spectrum. These limitations highlight the need for more dynamic and flexible multiple access techniques, especially in today's world of high bandwidth applications and an ever-increasing number of connected devices. FDMA, with its simple approach to dividing frequency bands, has played a significant role in the evolution of communication technologies. It provided a reliable solution for applications like early cellular networks and satellite communication, ensuring organized and efficient use of the limited frequency spectrum. However, as technology progressed and the demand for higher bandwidth and more users grew, the limitations of FDMA became apparent. Its inefficiency in handling dynamic traffic and accommodating a large number of users led to the adoption of more advanced multiple access techniques like TDMA and CDMA. Understanding FDMA remains important as it forms the foundation for more complex multiple access techniques. It provides valuable insights into the challenges of managing limited resources in a shared communication environment and highlights the continuous evolution of technology to meet the ever-growing demands of our connected world.